Hello, and welcome to another lesson, distance learning lesson, physics P2. This time we're going to be looking at distance and velocity versus time graphs. So hence we started off with the proclaimers. I would walk 5,000 miles. That's a very big distance. Okay, and the question that I'd like you to think about is, how are these graphs a bit like a story? Okay, so if we see here, there's an example of a distance time graph. Thanks, Siri. And it gives us some information. Okay, so as always, we're going to start off with a couple of quick questions. Here are our key words: so velocity, acceleration, gradient, and this term called stationary. Okay, so the journey of 1,000 miles starts with a single footstep. And that's how we might be feeling at the moment with regards to self-isolation, but we will get there. Just wait. Okay. So, question 1, what is the equation that relates speed, distance, and time? What is the equation that relates speed, distance, and time? Question 2, what is the charge on an electron? Is it positive, negative, or neutral? What is the charge on an electron? Is it positive, negative, or neutral? And question 3. What is the correct word equation for photosynthesis? What is the correct word equation for photosynthesis? So we've got carbon dioxide plus water goes to glucose plus oxygen. Oxygen plus water goes to glucose plus carbon dioxide. Carbon dioxide plus light goes to glucose plus oxygen. And finally, oxygen plus light goes to glucose plus carbon dioxide. Okay, so here are the answers. Distance equals speed times time, or speed equals distance divided by time. Charge on an electron is negative 1. Okay, and not quite sure why that one's popped up. So the correct equation for photosynthesis is carbon dioxide plus water goes to glucose plus oxygen. Remember, photosynthesis gives us sugar and oxygen. Okay, so what we're going to look at today, we're going to state the parts of a distance or displacement time graph. We're going to describe how to calculate the gradient of a displacement time graph, and we're going to use velocity time graphs to calculate acceleration. Okay, so last time we looked at how speed was related to distance and time and how to calculate acceleration. We can also use distance time graphs and velocity time graphs to perform calculations with regards to speed, distance, and acceleration. So that's what we're going to look at. Okay, so here we have an example of a distance, really a displacement time graph. Okay, and it's really important to read the information given to us. So we've got distance or displacement in miles on our y-axis, and we've got time in hours along our x-axis. Okay, so it's important to familiarize yourself with what we see on the graph grid as well. So what you notice is a variety of different stages. Okay, so stage A, stage B, stage C, stage D, and stage E. So this is really where this graph paints a story, okay, or tells us a story. And if you notice, there's some bits that are flat and other bits where it's increasing and one bit where it's decreasing. So that's really important to think about, okay? And I like to think of the story of a graph as the story of a gradient. Okay, so what we're going to look at now is how to use that gradient to tell us the velocity. Okay, but before that, just to reiterate this point, the story of a graph is the story of a gradient. Here is a classic that will really help us to remember that fact. Okay, or at least it would do if it wasn't there wasn't an ad first. Here we go. Where I go. Me and my friends at the table doing shots, tripping fast and we talk slow. Right, we get the idea. So that's I'm in love with the shape of you. And once again, the story of a graph is the story of its gradient. Okay, so we can calculate the speed or velocity from these distance time graphs. So if we remember, distance equals speed times time. So this means that the distance can be found by looking at the gradient of these graphs. So in its other arrangement, speed is distance divided by time, and if we go back, you see we've got distance on our y-axis and we've got time on our x-axis. So how does this link to gradient? Okay, so just as a reminder, the gradient is how much you go up or down for every one you go across on the x-axis. So you see here, this is a straight line with the gradient, which sometimes we give the letter m, is how much we go up or rise or fall for every one we go across. We can also say this is equal to the change in the y value divided by the change in x. So it's a change in y divided by change in x. And as once again, speed is distance divided by time. It's going to be the change in y divided by the change in x. Okay, so here we go. Here is our distance time graph, and what we're going to do is we're going to calculate the speed for these different regions. We're going to calculate the speed at these different regions. So section A, all right, we've got the gradient, so it's the change in y, how much it goes up in. So that's 2, 4 minus 0. That's the difference between those 2 points, divided by 1 minus 0, the difference along there. So that gives us a velocity of 4 miles per hour. And once again, the units are important. Okay, this next section is flat. Okay, this next section is flat. So I just want you to think, what might the velocity be at that point there? If this was a person who was going on a journey maybe to the shops, what have they done at this time point here? Okay. If you have thought that they were standing still, or what we call stationary, then you are absolutely correct. So if we do the calculations here at B, the gradient is 0. They are not going anywhere. They ain't going anywhere, son. Right? So there is no velocity. They are standing still at that point. Okay? So it's a plateau or a flat line. Plateau meaning plate, meaning flat. Okay? So now let's look at C. And for keen eyes amongst you, you'll notice it's got the same steepness, the same gradient. So the velocity at this point should be the same. Well, let's have a look. So our gradient is, if you look, we are going from a change in y is 8 minus 4. We've gone up 4. And we've gone across 1. We've gone from 2.5 minus 1.5 hours. So that gives us 8 minus 4 divided by 1, which is 4. So our gradient is 4 at that point. And remember, distance divided by time is the speed of velocity. So 4 divided by 1 gives us a velocity of 4 miles per hour. Okay, 4 miles per hour. Okay, so once again, we've come to D here. We come to D. Right, and so if you look at it, it's a flat line, it's plateaued, so the gradient should be 0. This individual is stationary. Maybe they've stopped to talk to a friend for an hour, okay, from 2.5 hours to 3.5 hours. Must be a very good friend to talk for that long. Okay, so just to confirm, a gradient at that point is 0, which means that individual, that object, that may be a car or a bike, is travelling at 0 miles per hour. Okay, finally section E. Right, this time you'll notice that if this is displacement, the person is maybe coming home from the shops, the gradient is decreasing. So their velocity is going to be a negative number. Their velocity is going to be a negative number. Sorry, bear with me. If you look section E, we are, so change in Y is minus 8 because it's gone down. It's gone down from 8 to 0. And the amount we've gone across in our x-axis, we've gone from 3.5 to 5.5. So that difference there, the change in the x is 2. So once again, we've gone from 8 down to 0, so that's minus 8, and we're dividing it by 2. Okay, so that gives a velocity of minus 4 miles per hour. Okay, that gives us a velocity of minus 4 miles per hour. Okay, hopefully we got that correct and or understood that. Okay, to make sure we are happy with that, I will upload a bicycle question sheet on Google Classroom for you to practice and submit as part of the assignment. Okay, if you finish that, then there's a further task, something called worksheet 2. Okay, so we've stated a part of a distance or a displacement time graph, what's on the y-axis, what's on the x-axis, the various stages within that. We're now going to, and we've also described how to calculate the gradient of a displacement time graph. Okay, that's what we just done, and we said it tells us a velocity. Okay, so for those of us aiming for sort of up to grade 4, that is a good place to finish. However, I would say this next section is the same skill, so it's not that much more difficult, so I recommend you stay on. Okay, and once again, remember, if you find any of the bits tricky, you can pause the video, read the notes, or go back to what I have said. Okay, so last objective, we're going to use velocity time graphs to calculate the acceleration. Okay, and the great thing is exactly the same skill as I said. Okay, so remember, velocity is related to time with the following equation. Okay, so acceleration is the change in velocity divided by time taken. So this is the final velocity minus the initial velocity divided by the time taken. Okay, so it's the final velocity minus the initial velocity divided by the time taken. Okay.
Hi, Dad. Can you say that again, please?
Right, so acceleration, one more time, is the change in velocity divided by time. So this means that acceleration can be found by looking at the gradient of a velocity time graph. Okay, and just a final point, the total distance travelled by that object or individual or car is the area under the graph, and we'll come on to that in a couple of slides' time. Okay, so here we go. So we have our velocity time graph. This time we've got velocity on our y-axis, not distance or displacement. Units really important.
Hi, Dan. Can you say that again, please?
Yeah, units are really important. Okay, so we've got meters per second and we've got seconds. Okay, so same skill, we're going to calculate the gradient of each section. Okay, so this will give us our acceleration. So if you look, we have change in y, or final velocity 20 minus initial velocity 0. Okay, and how much we've gone across, our time is 10. So this gives us 20 divided by 10, or 2 meters per second squared. Okay. Right, now B, if you notice, the gradient is 0, so our acceleration will be 0. Okay, although this time the person or car or bike will not be stationary, they'll be moving with a constant velocity of 20 meters per second. Okay, And finally, our acceleration at c, we've got our final velocity is 0 at this time point here, and our initial velocity is 20, so it's going to be 0 minus 20, and the time period, the time it's taken is, just double check, 15. Okay, so 0 minus 20 divided by 15. Okay, 0 minus 20 divided by 15. So it's 20 divided by 15, which will be minus 1.25 meters per second squared. Okay, minus 1.25 meters per second squared. Okay, I'll just double check that using my calculator. 20 divided by 15 equals 1 and a third. 1 and a third. Okay, I'll make sure I write that correctly. Always good to check your workings. Okay, so one more time. The acceleration at a is a gradient, which is a change in y divided by the change in x, which is 2 meters per second squared. Acceleration at b is 0 meters per second squared. And acceleration at c is a change in y, so 20 down to 0. Because it's decreasing, it'll be a negative acceleration, and the time period is 15. So it's 20 divided by 15, or minus 1.33 recurring meters per second squared. Okay, so now we're moving on to calculating the distance travelled. This is where we use more maths. So once again, your GCSE maths qualification, really, really important that you keep on top of that. And we're about to do a little bit more maths. Okay, so here we go. So if you remember from a couple of slides ago, the distance travelled is equal to the area under the graph. So it's the area of this triangle here, plus the area of this rectangle here, plus the area of this triangle here. Okay. So the area of triangle A is, if you remember, the area of a triangle is half the base times the height, or the base 10 times the height, 20 divided by 2. Okay, so it's a base 10 times the height, 20 divided by 2. Alright, so that's the area of a right angled triangle. Next bit is quite simple, so the base is 5 and the height is 20, so the area of this rectangle is 5 times 20. And finally we have our third triangle here. The area of that is, the base is 15 times the height, 20 divided by 2. So if we now put that into our calculator, we end up with 10 times 20 divided by 2, which is 100, 5 lots of 20, which is 100, and 15 times 20 divided by 2, which is 150. So the total distance travelled, represented by this velocity time graph, is 250 meters. 250 meters. Okay. All right. So that is us for today. So we have stated apart the different parts of a distance or a displacement time graph. Remember, the story of a graph is the story of a gradient. Yeah, and we can calculate the gradient of a displacement time graph. Okay, and if we calculate the gradient of a velocity time graph, then it allows us to calculate the acceleration. So, second lesson complete. Thank you so much for listening. Once again, any questions, please let me know. All right. Thank you.